Imagine this. You throw a book into a fire, and it burns to ashes. The information is still there, scattered in smoke, in heat, in molecules of carbon. But what if you throw that book into a black hole? Does the information vanish forever? This is the black hole information paradox, a mystery so profound that it challenges the very foundations of physics. It's the puzzle that kept Stephen Hawking awake at night. And today, I want to take you beyond the event horizon to confront one of the greatest riddles of the cosmos. As a scientist and explorer, I've spent decades studying the birth and death of stars. When a star collapses into a black hole, we understand its gravity, its mass, its pull. But the real puzzle begins when we ask, what happens to the information about everything that falls inside? In physics, information cannot be destroyed. It's a law as sacred as energy conservation. If I burn a tree, the atoms rearrange, but the blueprint of what it once was still lingers in the ashes and gases. Yet, black holes seem to break this sacred rule. Anything crossing the event horizon, stars, planets, light, entire civilizations erased, with no trace left in our universe. This clash between quantum mechanics, which insists information is eternal, and general relativity, which predicts its destruction, is what we call the information paradox. Let's break it down. Einstein's general relativity tells us black holes are cosmic prisons. Once inside, nothing escapes, not even light. Eventually, the matter collapses to a singularity, a point of infinite density. Information, it seems, is crushed out of existence. Quantum mechanics, on the other hand, screams impossible. The universe is built on probabilities, wave functions, and the conservation of information. If information truly disappears, the mathematics of quantum physics falls apart. It's like two giants, Einstein and quantum theory, locked in a cosmic battle, and the battlefield is the black hole. Over the years, scientists have proposed bold ideas. Hawking radiation in 1974. Stephen Hawking shocked the world. He suggested that black holes are not eternal. They slowly evaporate by releasing radiation. But here's the paradox. That radiation seemed random, carrying no imprint of what fell inside. It was as if the universe had a shredder. The holographic principle, some physicists, like Gerard T. Hooft and Leonard Susskind, suggested that all the information swallowed by a black hole is not destroyed, encoded on its surface. The event horizon, like a cosmic hologram. The three-dimensional reality might just be a projection from a two-dimensional boundary. Firewalls, another theory, says there could be a wall of fire at the event horizon, burning information into quantum energy before it crosses. But if this were true, Einstein's smooth, gentle spacetime would shatter into chaos. Wormholes and baby universes. A more radical idea. Information might not vanish at all, it might escape into another universe through a wormhole. If so, every black hole could be a cosmic bridge, rewriting not just physics, but philosophy. Few people outside the scientific community know how far this paradox stretches. Some physicists argue that the universe itself may be a black hole, born from an information paradox at the Big Bang. Others whisper about the possibility that information is not destroyed, but scrambled beyond recognition, like a cosmic encryption key no one yet knows how to decode. Recent work even suggests that gravitational waves, the ripples of colliding black holes, may carry hidden fingerprints of the information lost. Imagine the answers we seek could already be echoing through spacetime, if only we learn how to listen. When I look at the paradox, not as a scientist, but as a traveler of the cosmos, I see something deeper. The information paradox mirrors our own human struggle. We want to believe that nothing, no memory, no story, no life is ever truly lost. That even when we vanish, something of us remains, written into the fabric of existence. Maybe black holes are not erasers, but teachers. Maybe they whisper, even in darkness, nothing is wasted. Everything leaves a trace. So, does information vanish inside a black hole? Or is it preserved in ways we cannot yet imagine, written into holograms, scattered through radiation, or carried into universes beyond our own? The truth is, we don't know. Not yet. But in chasing this paradox, we're not just chasing equations, we're chasing the very nature of reality. And perhaps the greatest paradox of all is this: the more we stare into the abyss, the more it reflects back our own hunger to understand who we are and where we belong. If this journey left you with wonder, subscribe to Black Hole Secrets. Together, let's cross the event horizon of knowledge and explore the mysteries that still wait in the dark.